Welcome back. I go through some frustrating times right now, and I went by a literal scrap heap and I found this little beauty here, a D-box, and yeah, it's missing part of the front plate. If you don't know, the D-box, and I guess that's a D-box 1, were the first digital video broadcast receivers marketed here in Germany or Europe, aboutish 1996, I think. And yeah, well, there's nothing here. Nice display. We have a close-up on that in a second. Sub switches, and that's it. I guess this is for, you can pull that out. No, we'll see it later. But this is for encrypted broadcasts. So pay TV. That was also not the introduction, but the first digital pay TV. So on the back, let me have a little bit more focus here. So you have your TV connector, your antenna input, so this is for digital video broadcast terrestrial, 012 volts, VCR control, audio right left. I mean, this is also for controlling something. Yeah, VCR connector, SCART, TV connector, SCART, auxiliary connector, SCART, a plug for the telephone. Maybe, I don't know really, maybe there was even something like pay-per-view back then. So yeah, you wanted to view a certain movie on a certain channel, and you had to open an account with a telephone number and a credit card or something, and then it would literally phone home, and yeah, you got charged on your credit card. An RS-232 serial connector, wow, and a SCSI connector. And if you think you could connect external hard disk for recording on a hard disk, you are wrong. This was for SCSI connecting a CD-ROM, if I read the Wikipedia into right. Manufactured under license from TVCom International. I always was under the impression these things were made by Nokia, but Nokia only did the cable ones and the satellite ones, and this is, well, obviously for a normal terrestrial antenna. Anything else of worth? D-Box-C, 230 volts for Germany, US patents, blah blah blah, licensed for limited pay-per-view users only. Pay-per-view back then, wow, wired telephone. Analog telephone, made in Sweden, and that's the Nokia logo, so it is made by Nokia. Yeah, no date here, but serial number, yeah, that was back then. Telecommunications and everything was in the hand of the German government, so that's a proof mark approving this receiver. Anyway, anything else? No, absolutely not. So you know how they say on this channel, don't turn it apart, turn it on. Yeah. Okay, I don't think it was exposed to rain, at least not too much. So if I plug that in, woohoo, self-test beta research. I want to use Beta Nova. I want to use that display. Time synchronization. Does it has a time signal receiver inside? I have no idea. I will shut up now. Oh, weather. Weather F, so weather forecast. This is so cool. And I guess that's it. Is there a defect pixel or is that just a scratch on the display? Ah, no, it's actually a crack in the display. So you have here, this is just some reflections on the crack here on the front. But nevertheless, I want this display. Oh! Cinema World. Motors. No. Sci-fi. Oh, let's go back. History. Oh, another porn channel. Be user. That's Beate user. That was a big chain of you know, sleazy shops where you could buy the sleazy stuff. MGM. I'm so sorry. I'm just rambling away. It was a frustrating day. I tell you the story. I'm back on time synchronization. Okay, that's it. It's obviously still working, at least the display, which is nice. So let's take it apart. I unplugged it. Yeah, it's the right plug. Okay, and they need special tools. Just a sec. Yeah, they are. Oh, my fingers drowned out. They're using these security bolts here, or screws, but yeah, I've got the remedy. Okay, let's get cracking. So they really don't want people to peek inside here because it's all very proprietary, and I read on the internet while searching for D-Box that there are also, you know, hacks because pay TV. And we're in. Nothing here. So, oh, let's have a peek inside. And tell you what, let me clean that up here at least a little bit before we continue. So, much better. Not good, but better. Where was I? Yeah, and let's get that front panel here off. This is... Can I have a focus up here? This is obviously an intelligent display, so it has some blobbed chips on board, and I guess that's only power and a serial interface, and it's from Siemens. Wow. And here I need some really small stuff. I don't know if I have that. Give me another sec. Yes, I have. These are really small screws here. The backplate doesn't come off yet. I guess we need to lose more screws. And yeah, that's the telephone subboard, and yeah, there are just here some metal tabs holding it in. So that thing is phoning home via analog telephone, and we will have a detailed look at that later. Yeah. This was the antenna input, or is it the television? No, that's the television and antenna output, and it's connected the antenna input, television output. Well, this coax here, how did they get that in, I wonder? That's basically impossible. To this board, which obviously does terrestrial Television frequencies, more screws, of course. And that has obviously a digital connection to the main board. So this lifts out as a whole chassis, and then you have the bottom of the case underneath, which is just plastic. And now we can have a detailed look. I mean, this obviously is the digital encoding stuff here on the main board. And I can't get the sticker off. But yeah, it's like a what were they called? PCMCIA cards, but it's really thick. We'll take that apart too, I guess. Let me clean up some more. This is too dusty to touch. The back still won't come off. Yeah, but we can hopefully detach. Let's first do the back, and I forgot the screws of the RS-232. And now it comes off. Very nice. And now we can have a look-see. Okay, 230 volts come in here, and yeah, the plastic is all nice connector though. So let's see, what do we have here? So mains AC coming in here, there's some input filtering, and I guess that's a 4 pins, common mode choke, no problem. And then we obviously have a switch mode power supply here. That was a CAN for terrestrial television. And yeah, that was routed right away to that other board here, which we'll look at later. Then here our SCART connectors. Here's the SCSI connector that happens here in that part. Yeah, that's it. It's complicated. It will be interesting to see which chips are used here and what they are doing. Can I lift that off? Yeah. Okay, so that was destructive. That's obviously only a housing for another card or something, but yeah, it's empty. Okay, let's have a look at the chips then. Before we actually look at the chips, some more details about that switch mode power supply. So that's the high voltage side, and you see here the optocoupler for the feedback from low voltage to high voltage, which is probably driven by that little tranny. That thingy here has only 2 pins. That's a big ass rectifier diode. But we also have here 1, 2, 3, 4 diodes scattered, which are probably a bridge rectifier, so you get 2 voltages out on the secondary side. The thing here, it's primitive. It has only 3 pins, so that's really a very simple switch mode control and yeah, tranny chip. So all in one. On the center of the board, we find a C-Cube CL9100P160. That's an MPEG decoder or multi-video decoder. And it also does some on-screen stuff. Yeah, it can talk to a CPU or microcontroller. And basically you get a 1-bit bit stream, MPEG bit stream in, and you get 8-bit parallel bit stream, still MPEG-ish out. And then we have that big thingy here, that's a Philips SAA7124WP. And that's finally the digital video encoder. that takes the 8-bit MPEG stream from that thing and turns it into RGB analog signals. So that thing has the digital analog converters inside, either PAL or NTSC. These 4 things belong obviously to our C-Cube according to the datasheets. That's DRAM chips, HM414260s, 256K times 16-bit. So a full megabyte of DRAM supporting that thing here. We have this little bugger here, the TEA5114. That's just an RGB switch. 2 inputs, yeah, times 3 or 4 and 3 or 4 outputs. And of course, that's for switching between the different SCART connectors here. I forget that one almost. That's a Crystal CS4920A multi-standard audio decoder. So that's also a digital to analog converter, and it eats MPEG. That's it. Yeah, this is just a linear voltage regulator. 4-pin jobby, variable output voltage, PQ20RV. And I guess some of these chips need 3.3 volts, possibly the C-Cube and the DRAMs. I turned the board 90 degrees to get everything here under the camera. So we were over here. That was the big C-Cube thing, and that was the big Philips thing. And now we are going, yeah, digital. So this here is an AMD AM536F94JC SCSI 2 controller for the SCSI interface, which, remember, just takes a CD-ROM or something like that. Anyway, beside it here we have an MTEL ATF16F8BQL. That's a programmable logic device with 250 gates, and it's electrically erasable. And finally here, that poor little bugger, that's our Motorola 6834OPV-16E. 32-bit processor with DMA. And it doesn't stop there. Down here, these 2 big blobs, these are, I think it's now from Lattice, PAL CE 16V8Q-15PC/4. Yeah, these are also electrically erasable CMOS programmable array logics. Okay, 2 of them. And to be symmetric, we have 2 of those little buggers. And these are simply Motorola 74F257As quad 2-to-1 multiplexers with 3-state outputs. And for that processor, we have again here 2 DRAM chips, the same we had before, the HMS 14260C G7 256K times 16 bits. So, yeah, RAM. And finally, that little thingy here. Sorry for the church bells. Finally, that little thingy here, an AMD AM29F800B. That's 8 megabits of flash memory for our processor, of course. Almost forgot it, we got another PQ20RV voltage regulator adjustable up here, because all that SCSI stuff is 3.3 volts, and as far as I can see, that stuff down here is 5 volts. And I do have to return to the other side once more, because, yeah, under this plastic hood here, there was a Lucent AV6220A27G hiding, and that's an MPEG-2 system layer demultiplexer. So it takes an MPEG-2 stream, data stream, with audio, with video, with additional informations, and splits it into an MPEG video and an MPEG audio stream. And remember, the video stream is first processed by the C-Cube here and then further put into an RGB signal by that Philips jobby here, and the crystal up here was doing the decoding, or the analog, the digital to analog decoding for the MPEG audio. And if you thought you have seen everything, you don't. Yeah. There are more chips on the back. Give me a second. Okay, let's do that quadrant by quadrant, just for your orientation. That's the backside of the high voltage part of the power supply. And yeah, here you can see there are our SCART connectors. And right there we find 1, 2, 3 Motorola's 14053Bs. These are triple 2-to-1 analog switches, and of course they are switching the RGB lines to the SCART connectors, and they are probably all driven by that neat little thing here. That's a 74HCT259D. So that's a 3-to-8 decoder that is with just 3 data lines. You can set 1 of 8 bits, and these are followed by 8 latches. So you can, remote controlled by the processor or somewhere, set one of the or all of the 8 output bits individually, and just need to drive 3 data lines. We're looking now at the quadrant directly below what we just looked at. This is the edge of the high voltage area of the power supply. There are no big chips anywhere in the vicinity on the other side, but there is that plastic slide-in case here for 8 contact ID or whatever card. 1, 2, 3, 4, and up here 5, 6, 7, 8 pins it was. Anyway, we find again here 2 of the 74 HCT259Ds, 3-to-8 decoders, plus 8 latches for the outputs. We have here a 74 AC04 hex inverter, and interestingly, the first analog part, that's a TL082C dual JFET op amp. And then we have here more glue logic. These are 2 74 F08Ds, quad input and gates. And these big thingies here, these are 74 F541s, octal buffer drivers with 3 state outputs. So and not to forget that little thing here, 74HC174, a hex D-type flip-flop with clear. And we talk about that thing in the next quadrant. Next quadrant, we were just looking at these chips here, and again, no big chips on the other side, and but the big connector here where the fat decoder card slotted in, and here the flat flex goes up to the PAL television signal daughter board. So we have 1, 2, 3 in a row. Maybe RGB, I'm not quite sure, but these are 74 F257As. So quad 2-to-1 multiplexer with 3 state outputs. So might be RGB bit streams, but 3 state outputs it's definitely handling some kind of digital bus. Down below here we have a simple 74F02D quad 2-input NOR gate. Right above here, that little guy, it's the 74HCT74D, the dual D-type flip-flop with set and reset. We have a 74F138, a 328 decoder, multiplexer, not demultiplexer, multiplexer. And finally, the big job here, the 74F541 octal buffer drivers with 3-state outputs. You probably noticed they are reusing chips all the time, which is cost-wise a good thing. Okay, next quadrant and last quadrant for the main board. The last quadrant also holds no surprises. That was the last chip we looked on, so we were below here somewhere. Around here is the processor on the other side, but there's not much here. There's a 74F04D hex inverter and a 74HCT74D, we already saw that before, dual D-type flip-flop with set and reset. Then we have 74F138, 328 decoder multiplexer, yeah, glue logic. Up here a 74F245D octal transceiver with 3 states input outputs. So they are switching here somehow an 8-bit digital bus. And yeah, no surprise, there's the RS232 connector. We have a MAX 202 dual RS232 line driver receiver. So 25 chips on the back and 19, of course, the big ones on the front. A total of 44 chips. Let's just for a little bit of relaxation have a look inside the can here. That was easy. Backside is also quite easy. Let me try to zoom in. Backside is uninspiring. There's not even a high frequency transistors here, just resistors and capacitors. On the front side we have an inductor, that is, we have 2 inductors. Yeah, there's the second inductor. There was the first one, getting out of focus, but there's the second inductor. From the other side we see a little ferrite bead here. Further down another, that's the third inductor. And just here, 1 transistor, nothing else. If you consider the functionality of that can, it's not surprising. So antenna signal goes in here, of course, and yeah, it's sent over to that daughter board which does the PAL video stuff. And the daughter board may or not, may or may not, I'm not quite sure, send some signal back, some decoded television signal that then goes out to the television. It might well be that the decoded signal is only available through the SCART connector, so you were forced to use a television with a SCART. Anyway, maybe there's also a bypass directly from the antenna input to the television output. And then there was the PAL daughter board, which communicates to the main board just digitally, yeah, just judging by the connector. And yeah, television frequency signal comes and goes out here into the can. But let's go over the chips real fast. We have here a Philips S87C654-4A44. That's an 8-bit microcontroller with 16K EEPROM, not EEPROM, not flash, EEPROM. Yeah, program it once. No, you can erase it actually. Erasable PROM. And 256 bytes of RAM. We have here a mystery chip from TV.com. I'll give you a zoom. Got absolutely nothing for that thing. I guess it has to do something with encoding, decoding. Who knows? We have another mystery chip here, 6 pins. I think it's some analog jobby, maybe even a transistor array or something. As I said, 3 pins in, 3 pins out. It's marked 11.05Y. Then, not the core, that's the core, we have Intersil HI5703 KCB 10-bit analog to digital converter, 40 megasamples per second. Yeah, remember, the television signal has to be digitized, has to be somehow decoded and then fed back into the television, that you can actually see your pay TV or pay-per-view TV. Next we have a little 74 AC 11074, a dual D-type flip-flop with clear and preset. 34071, that's just a little op amp. Here our oscillator. Further down, LM358 classic dual op amp. Then a 385 voltage reference. That's very interesting. By the way, here's a relay. Then that thing marked X6981M. That's a bandpass filter. Okay. Finally, we have here a Philips NE5219D variable gain wideband amplifier. So we have everything here. I don't know why they need the relay here. To digitize the signal from the television station, from the pay TV signal, and send it to the main board. The only thing I'm missing here is, the other way around. I don't think that 8-bit microcontroller has enough oomph to, through PWM or built-in analog, digital analog converters to recreate a television signal. So what I said, this might be bidirectional. It's probably not. The television signal is fed in here. It's converted here into digital, sent down to the main board where it is, if it's pay TV, decoded and then sent out as RGB signals through the SCART connectors to the television. Okay, let's crack open the can. That might be destructive because I see solder. Only a few spots, but yeah. They're cracking. No problem. And we see nothing. I will have to desolder that or get the board out. I don't know. Do we really expect to see something in here? I mean, you can see here, there will be some trannies on the backside, some inductors and so on. This is basically only the receiver unit that, takes the television carrier frequency and extracts the intermediate frequency signal. We've seen that before in another breakdown, teardown card here, link in the description. Yeah. Some delay lines. I zoom down. Yeah, some high frequency stuff, delay lines here, but we will find nothing interesting on the other side but some high frequency transistors. And remember, the main oscillator was over here. And there's really just that board. There is nothing populated, yeah, here on the carrier board of the CAN. It's just ground plane. The second daughter board was for analog telephony. Yeah, that was your analog telephone plug here. And yeah, it's connected to the main board just, yeah, via a few pins, some digital information. And we have here a Rockwell RC9624DP data fax modem data pump, 2400 bits per second. And we have here some Philips AT159-01FMOD. I didn't find anything about it, but since both have their own crystal, I guess it's another little microcontroller here that does all the thing. And in between, we have a 74HCT573D octal D-type latch, a 3-state. So yeah, some communication here. Now, before we have a look at these goodies here and these two, we have a look at the back side. There's nothing but a whole isolation area. Maybe you don't know, but analog telephony uses quite high voltages. You have in extreme cases to expect here 105 volts DC, at least here in Germany, and 75 volts AC. Yeah, normally it's a little bit, yeah, 60 volts DC is normal, and I don't know, 40 volts AC or something. But yeah, the voltages here can go up quite high, and so this is basically like in a power supply. Isolation area. And now we can look at the parts on the other side. So this is an ETAL P1200 line matching transformer. So it takes on here the digital signals or pseudo analog signals, at least 5 volt levels from the modem, and translates that to the voltage levels of your analog telephone line. And of course, it also does isolate our digital part from our analog high voltage part. We have here two little relays, double pull, double throw from Takamizawa BA5W-K. Yeah, somebody has to be able to pick up the virtual receiver here to yeah, start dialing, probably the second relay, start dialing, and yeah, establish the connection to the host of the pay television provider on the other end of that connector somewhere in the world. We have also two optocouplers that go up in, I don't know in which direction they go, doesn't matter. And we have here a read relay that goes definitely into the other direction. It's a Meter, yeah, German company, DIL, so dual inline CL-1A81-9-13M. And yeah, the coil in this relay is on the high voltage side, and there's only a single contact here on the low voltage side. I don't know why they need that. I mean, they have optocouplers to detect anything that's going on this side. But yeah, anyway, there it is. And the coils for these relays, they are here controlled probably by the microcontroller unit. And yeah, the switching is on the high voltage side. And then we have the, yeah, probably the key card for your pay TV that was slotted in from the front. And I will try to break that apart destructively. Oh, more chips. Who would have thought? I'll try if I can get the Other metal sheet of 2. Yeah. Oh, okay. Double-sided. Let me have a look, see what we have here. So, we have here 7165 8 kilobyte SRAM, 71256 23 kilobytes of SRAM, and M27C 512. That's 64 kilobyte of EEPROM, and we have here, of course, an ST90R52. I didn't find anything on the 52 variant, but that's another microcontroller unit. Why they need 2 crystals here, I have no idea. Anyway, some glue logic, 74AC132, Quad 2 input, NAND, Schmidt trigger. Why do they need a Schmidt trigger? I don't know. Then 74HC02, just your Quad 2 input NOR gates. And here the ST24C021 supervisory circuit. With an I2C, a CMOS EEPROM, precision reset control, and a watchdog timer. Yeah, somebody has to watch that little guy. And then I have here a mystery chip. The ERDETO MB87D205B. I found some Dutch forum entries that were talking about pay TV. So I guess this is really the, the encryption stuff in here, in that thingy. Just some glue logic on the backside, 74AC139, dual 1 of 4 decoder, demultiplexer, 74AC02, we saw that before, Quad 2 input, NOR gate, 74HC73D, dual, that's new, dual JK flip-flop with reset, and 74HC03, we had that also before, a Quad 2 input NAND gate. Last but not least, our 8-character LED matrix display from Siemens. This way around. SDA 5708. I even found a web page where they give you the pin out for the thing. It's an SPI device. Yeah, and there's also a library code available, so that's a keeper. And that was the teardown of D-Box 1 from the Scrapheap for digital video broadcast, terrestrial, pay TV and pay-per-view TV via analog telephone connection. If I didn't lose count, there are 69 chips in that thing. Can you believe the costs, the BOM costs of that? So I guess back in the days, so late 1990s, there was still a whole lot of money to make in pay TV. Till next time, bye.